Okay, so last day we talked about the idea of how we can find factors, sort of briefly. But let's make it really clear here. If we were to do this, 5 goes into 25 5 times with remainder 0. So most of you probably go, yeah, 5 is a factor of 25. You know it's divisible evenly, but we don't really want to think about it as divisible evenly. It's going to be more helpful for us to think about it as remainder 0. Same thing will happen if we were to look at 23 going into 100. So 23 into 100, if I go 4 times, it's going to give me 92. So this has remainder 8. So, again, most of you would probably say, no, 23 is not a factor of 100 because you probably realize that it won't divide evenly. But again, the idea is if it doesn't divide evenly, then the remainder here, it won't be equal to a 0. So if it's a 0, we have a factor. If it is not a 0, it is not a factor. And that's what we've got here. So determining a factor, it must have remainder of 0. Okay. So here's, we'll just verify it quickly with an easy example, one that you guys should know from, being able to factor this the way we practice with quadratics. So this one would be x plus 2 times x plus 3. We could factor that, but let's verify that this factor theorem actually works. What number am I going to use to calculate the remainder here?
-3.
Yeah, so -3 is going to be the value. So if I put it in, -3 squared plus 5 times -3 plus 6, so that's 9 minus 15 plus 6, which is 0. So it is actually has remainder 0, and we know that it's one of the factors. Okay, so again, I'll verify it again on the other side. The number I'd be using is -2. So -2 squared plus 5 times -2 plus 6. That's going to be 10 minus 10. So again, it's 0. So it works for both factors that I get a remainder of 0. Okay? So this is what brings us to what's known as the factor theorem. So basically what you're thinking of is this is the remainder theorem here. It's a special case of the remainder theorem. Okay, so it's basically we're using the remainder theorem, but we're only interested in remainders of 0. We're not interested if the remainder isn't. It means it's not a factor if the remainder is not a 0. So, move on. So sometimes we just want to know, are these factors? So I'm going to let you check in your calculator. I just want to know simply yes or no, are these factors of those polynomials? Okay, so did anybody manage to find a factor here? Maybe if I label this like, let's call this 1, 2, and 3. Did anybody find a factor of those 3 choices? Just 1 second here. John, go for it.
Number 1.
Number 1, yes. When I checked, the remainder was equal to 0. It is a factor. Don't take my word for it because you know how many mistakes I've been prone to make in my calculator. But John also agrees, so I'm going to say I'm pretty confident that it's a factor for number 1. Okay, what else? Did you find any other factors? Sure, Alice, why don't you...
Number 3 is a factor.
Yeah, number 3, if you check the remainder here is equal to 0. And I know we probably don't need this reminder at this point, but in this one I'd be using x equals to 1 in here. So you end up with a remainder, I believe, of 7 when you substitute. So remainder is 7. This one is not a factor. Was it 7?
Yep.
Okay. So here is an example of where you might see that sort of thing appear. Multiple choice question. Which one of these is a factor? In this case, it may be more than one, but let's just, we'll take a look and see which ones may or may not be factors of that polynomial. So it's kind of like a search you would do on a test or a quiz. Okay, so I ended up with 3 factors. Hopefully you found at least 1 or 2 by now in your calculator. I end up with these 3 here being factors having remainder equal to 0. When I put in 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6, I get 0. So that one was one of mine. For this one, I'm going to use x equals to 2. So I get 2 cubed minus 6 times 2 squared plus 11 times 2 minus 6, which was a 0. And finally, this one was also a factor. And 11 times 3 minus 6, which was also equal to 0. So those 3 turned out to be factors. This one, when I put it in my polynomial, the remainder ended up being, I think, negative 60. Okay? So, now it's very similar to the remainder theorem, but it's not stated for you what the remainder is. So when you read this, it says find the value so that x plus 1 is a factor of this polynomial. So what does that mean? To guarantee it's a factor, what do I have to do? What equals to 0? Yeah, so if I put in the value, I want it so that f of negative 1 equals to 0. The remainder's equal to 0. Okay, so see if you can figure it out. What value will guarantee that x plus 1 is a factor of it? Okay, so we put in negative 1 for the value of x, plus 4 times negative 1 cubed, plus a times negative 1 squared, plus 4 times negative 1 plus 1, and it all has to be equal to 0. So that means that 1 minus 4 plus a minus 4 plus 1 equals 0. So that'll be, looks like a minus 6 equals 0. So at a equals to 6, that will guarantee that x plus 1 is a factor.